Good morning. I miss all of you, and I hope you are staying healthy. Today we're going to look at the second method for solving systems of equation, and that method's going to be substitution. I anticipate that this will be 2 videos because I can only video for 15 minutes and then it cuts it off. So should the lesson get cut off, I will start exactly where I ended in the second part of the video. So in order to use substitution to solve systems of equations, there are some steps to follow. I'll read the 4 steps. They don't really make a lot of sense until we actually start applying them and actually solving a system using substitution. So the first step says to solve one equation for one variable. Basically, that means you're going to get one of the variables on either the left or the right side all by itself. Once you do that, whatever that variable equals, you will substitute it in for that variable in the next equation, the other equation. You will then solve and you will get an answer. When you get that answer, you substitute it back into one of the equations. It really doesn't matter. I try to choose the easiest one to substitute it back into, and then you'll have the value for both of your variables. This will be the point that is that makes it true for the equation. Okay, so let's begin with some practice. Number one, our system is y equals 6x and x plus y equals 28. So I have 2 linear equations. I look at both of them. I notice that the first one is already solved for y. Y is by itself. So I will be taking what y equals. It equals 6x, and I will be plugging it into the equation below for y. So the new equation becomes x plus, instead y, it's x plus 6x equals 28. I'm going to add the like terms and get 7x equals 28. I'm going to divide by 7, and I get x equals 4. Now you can technically take that value of x equals 4 and plug it into either of them. I'm just going to choose to plug it back into the top one because it's the easiest. So I get y equals 6. Instead of times x, I do 6 times 4. So y equals 24. My solution is the ordered pair. Alphabetically, x comes before y, so it's 424. And that's my answer. You should be able to plug that in and it should make both equations true. Okay, let's try another one. 2x plus y equals 9. X plus 4y equals 1. So I look at both of these equations and I notice that neither of them has x equals or y equals by itself. It's not, we do not have a variable isolated by itself. So you have choices. And the next thing you want to look at is the coefficients in front of your x and y. If you notice in 2x plus y equals 9, y has a coefficient of 1. So we could definitely solve the top equation in terms of y. If I look at the second equation, x plus 4y equals 1, I notice the coefficient in front of the x is 1. So I have the option of solving that equation in terms of x. Because the second equation is easier to for me to just solve in terms of x, because I can just start solving it right there, I'm going to subtract 4y. And I get x equals 1 minus 4y. Again, you could have chose the top equation and solved it in terms of y. This equation is now solved in terms of x. So in the top equation, wherever there is an x, I will replace it with 1 minus 4y. So I'm going to rewrite the top equation, and I have 2, but instead of x, I'm putting times 1 minus 4y plus y equals 9. I'm going to solve by distributing that 2. So 2 times 1 is 2. 2 times negative 4y is negative 8y plus y equals 9. Now I'm going to combine like terms. 2 negative 8y plus y is negative 7y equals 9. Now I'm going to go ahead and I'm going to subtract 2 so I can get y by itself, and I get negative 7y equals 7. I'm going to divide by negative 7 and get y equals negative 1. You can choose again to put that value of y into either equation. I'm going to just put it into this one right here. So I get x equals 1 minus 4 times negative 1. And negative 4 times negative 1 makes a positive, so I get x equals 1 plus 4, or x equals 5. Now I know what x and y equal, and my solution is x comes before y, so it's 5 comma negative 1. That's the solution. If you plug that in, it should make it true. Okay, let's go to a third one. X minus, let me start over with that one. C minus D equals 8. C over 5, or C divided by 5, equals D plus 4. Okay, so let's see how we want to go about solving this. I think I will solve in terms of D for the top equation. So if I do that, I'm going to subtract D. So let's do that over here. Let me do it in another color. So C minus D equals 8. I'm going to solve in terms of D, so I'm going to subtract C. I have negative D equals negative C plus 8. You can divide through by negative 1 so that you have D equals C minus 8. So I'm going to take that, and in this equation, the second equation, wherever there's a D, I'm replacing D with C minus 8. So I get C over 5 equals, instead of D, C minus 8 plus 4. Let's combine those like terms and get C over 5 equals C minus 4. Okay? So you can do this a couple of ways from here. It looks like I have somewhat of a fraction or ratio on the left equals C minus 4. I can turn that into a fraction, and then it might be just easiest to cross multiply. So I get 1 times C equals 1C equals 5 times C minus 4. Or I get 1C equals 5C minus 20 because I'm distributing. I'm going to subtract 5C. And I get negative 4C equals negative 20. I divide by negative 4, and C equals 5. I'm going to take what C equals, and I'm now going to go and plug it in right there to D. So I get D equals C, which is 5 minus 8, or D equals negative 3. Again, there's a couple ways that you can solve these. So you may have chose a different one to solve in terms of, and that is totally fine. C comes before D, so my solution is 5, negative 3. Okay. Let's do one more together. Let's see if I have some more space here to fit in this last one. I'm going to try. We'll see what happens. Number 4. I have 3x minus 2y equals 11, and x minus 2 equals negative 4y. So if I'm looking at these two linear equations, I'm definitely going to solve the second one in terms of x. So I'm going to add 2 to the other side, and I'm going to say x equals negative 4y plus 2. I'm going to box that, because now I'm going to take and put wherever there is an x in the first equation, I'm going to replace it with negative 4y plus 2. So I get 3 times negative 4y plus 2y equals 11. I'm going to distribute my 3. I'm going to draw a little squiggly here so we don't get those confused. And I get negative 12y plus 6 plus 2y equals 11. I'm going to combine my like terms. Negative 12y plus 2y is negative 10y plus 6 equals 11. I'm going to subtract 6. Negative 10y equals 5. I'm going to divide by negative 10. And 5 divided by negative 10 equals negative 1/2. So I know what y is. Y is negative 1/2. I'm going to take it and put it back in here. So I get x equals negative 4 times negative 1/2 plus 2. And two negatives, when multiplied, make a positive. And I take half of 4, I get 2. So 2 plus 2, or x equals 4. My ordered pair is written alphabetically, so my answer or my solution is 4, negative 1/2, which means for all of these, if these were to be graphed, this is where their point of intersection would be on a coordinate plane. Okay, I want you to try a few on your own. So let me arrow down here and give you a few practice. I'm also going to list the answers, so as you try these, you can make sure you get the correct solutions. We did 4 together, so let's make this number 5. Your system is 3x plus y equals 4. Your next equation in the system is 2x minus y equals 6. Your solution should be, when you solve this using substitution, 2, negative 2. All right, try number 6. Y equals 2x plus 3. Y equals 4x plus 4. So both of these are already solved in terms of y. I'm going to help you out a little bit because sometimes students get confused when both are solved in terms of y. You just pick one. It doesn't matter which one you pick. So you're going to take, if I choose the first one, and where there's a y in the second equation, which is right here, you're going to replace that with 2x plus 3. Your solution should be x is negative 1/2 and y is 2. All right, let's go to the last one I want you to try. Negative 4x plus y equals 6, and negative 5x minus y equals 21. Your solution is negative 3 for x and negative 6 for y. Okay, so I'm going to stop this part 1 of our lesson here so that you can practice those 3 problems before we go to part 2, which is going to be doing some word problems on the back. So go ahead and take a few minutes to do those and make sure you get those solutions. If you don't, feel free to message me and we can go over those. All right, I will see you in a little bit for part 2.